Hi, I'm Alex from the Zscaler Customer Success and Engineering team. In this series of short videos, we're taking a look at the baseline recommendations for the configuration of ZPA. This is part 2, Architecture and Deployment. Now that we understand something of the value of ZPA, let's talk about the different components that are involved architecturally. Let's start with authentication. Here on the left, we have users connecting to the Zero Trust Exchange to access their applications. As discussed, the first step of this access involves authenticating with their IDP. ZPA requires an IDP that is SAML 2.0 compliant. This is most IDPs on the market, for example, Azure AD, Okta, Ping Federate, ADFS, etc., etc. ZPA also supports the use of SCIM. SCIM can push user and group attributes to the cloud. This enables Zscaler private access to consume that data directly from the IDP. For example, who is the user and what groups are they in? This is optional, but it is recommended as it allows the use of advanced features such as AI-powered application segmentation, which we'll talk about a little bit later. Next, let's talk about infrastructure. First, it's important to note that ZPA requires users to have Zscaler Client Connector installed on their devices. Zscaler Client Connector, or ZCC, is what's responsible for routing traffic from the user devices to the Zero Trust Exchange and to the ZPA service. That traffic is routed through two infrastructure components. The first of these are public or private service edges. These are responsible for brokering connections between users and applications. Public service edges sit in the Zscaler cloud. Private service edges are deployed on your network and enable a number of features such as providing optimal application access in countries where Zscaler does not have a point of presence, business continuity plans, or connecting users to a trusted corporate network and applications directly on it. The second component are app connectors. App connectors sit next to your applications, behind your firewall, inside your internal network. Note that in some cases, app connectors may reside within a DMZ. This is supported as a use case, but not illustrated here. Network access rules for app connectors are fairly simple. They need access to Zscaler, inside app connections only, no inbound rules. They need to have access to your applications across TCP, UDP, and ICMP for monitoring. And finally, they need to have unrestricted DNS resolution, both internal and external. For outbound connections between the app connectors and the Zero Trust Exchange, you'll find that the Zscaler public IP ranges are published on our website within the deployment documentation. An important consideration, both for private service edge and app connector deployment, is that these follow an N+1 deployment model. Both the PSCs and app connectors have a defined throughput. You should size the number of PSCs or app connectors deployed to the expected throughput based on the number of users you have, the connections you're expecting, and the amount of traffic that needs to be routed through these components. This means that if you expect, for example, a traffic of 1 gig per second with 40,000 simultaneous connections to one data center, you should deploy a minimum of 3 app connectors to that data center. 2 to handle the expected throughput, and an additional third app connector to ensure high availability and fault tolerance. Finally, we'll briefly talk about policies, though this will be covered in more detail in a later video. There are 3 components to policy. The forwarding policy, which determines when traffic is forwarded by the Zscaler Client Connector. By default, this forwards all traffic. The timeout policy, which is how often users are forced to re-authenticate. This by default is 7 days. And the access policy, which defines applications that users have access. ZPA functions with a default deny all access model, meaning that if an application access policy has not been defined to allow users access to applications, users will not be able to access those applications. Next, let's talk about actually deploying the ZPA infrastructure components. The first step in deploying ZPA infrastructure is to deploy Zscaler Client Connectors through users through MDM. If your users are already using Zscaler Client Connector as part of Zscaler Internet Access, then there's no additional deployment required. You'll simply need to activate the ZPA service inside the Zscaler Client Connector portal once you're ready. The next step is to deploy application connectors in your internal network, or DMZ. As mentioned, you'll need to configure firewall rules to allow for outbound access only. App connectors will need to be able to route to your applications and the internet. They'll also need to be able to resolve internet DNS and internal DNS. Finally, they will become the source IP for internal traffic. Next, you'll want to configure identity. First, a SAML IDP should be available to the client. It's important that the user can access the SAML identity provider. For transparent SSO to happen, there is a requirement to have access to either the Kerberos distribution center or to be able to present PRTs, primary refresh tokens. Next, you'll configure SAML authentication. Your configuration here is separate for ZIA and ZPA, so whatever you need to do for ZPA will not impact your ZIA configuration and vice versa. You'll want to configure which SAML attributes are returned. You can configure any number of SAML attributes for your IDP to be returned to ZPA. ZPA can consume device membership or other attributes, such as did the user do device authentication, what form of multi-factor authentication did the user present, what is the device ID, as well as user and group membership information. Any information the SAML IDP knows about the user in the device authentication process can be returned to us as a SAML attribute. Note that by default, SAML attributes are only updated during reauthentication. This is why we recommend configuring SCIM synchronization if your IDP supports this, since SCIM can update attributes as they change on the IDP, and SCIM can also revoke access dynamically if a user account is disabled. Note that since SCIM synchronization can take quite a bit of time, it's important that you ensure SCIM is synchronized before policy leverages it. Next, we need to deploy app connectors wherever applications are. Here, there are a number of important considerations to keep in mind. The first of these is that app connectors should always be deployed in at least pairs. This allows for failover and resiliency. For example, when app connectors perform upgrades, one app connector will always remain available to guarantee continuous access to your applications. The next consideration is that it's important to make sure you deploy app connectors in each data center, and that each data center maps to a different app connector group. This is because ZPA will select app connector groups to load balance connectors across app connectors within the group. Next, as mentioned before, you need to ensure that app connectors can reach the internet and that app connectors can reach your internal applications. Note that this does not mean that all app connectors need to reach all internal applications. Simply the app connectors that are mapped to a specific application need to be able to reach that application. Note that app connectors also need to be able to health check applications. So for example, if a web server is on port 80, then the app connector will open a connection on port 80 to check that it's available by checking the path and the round trip time. If it is a UDP application, for example RDP, that application availability will be inferred via a previous TCP health check or with an ICMP request. You'll want to make sure that TCP, UDP, and ICMP are available to your applications from app connectors. Finally, it's important to realize that since this is a zero trust network access environment, the client will never get the actual IP address of the application. The client will never be placed on the network, and will never get an IP address on the network. Since we're entirely segmenting the user from the network, the source IP address of requests made to the applications will always be the IP address of the app connector. This means services that rely on knowing the source IP, whether for routing or load balancing purposes, will not receive the IP address of the client. It's critical that the IP address of the app connectors are registered within Active Directory sites and services. To understand where to place app connectors, let's take a closer look at the app connector selection logic. First, when configuring access policies, as we'll see a little bit later, the app connector selection method can be configured. By default, this is closer to the user, but there's also an optional closer to the application method. Next, ZPA will establish a list of eligible application connectors that can connect to the application. ZPA will do this by checking health data to find connectors with valid paths to the application. From this pool, ZPA will find the path with the closest geographic proximity to the requesting client. Distance is calculated from the defined location of the connector and the geo-IP of the client, IP that is seen by the broker. All paths involving a connector with a geographic distance of more than 200 miles from the user will be removed. ZPA will then find the paths with the least latency, with the lowest RTT, from the connector to the server. Once all this is done, the resulting final pool of eligible app connectors involves all connectors that can reach the application, which are within 200 milliseconds of the client, and within 2 milliseconds of the lowest connector to server RTT. From those, ZPA will randomly select a path, then create a sticky cache for this decision, which is valid for 30 minutes from last access. Next, you'll want to deploy LSS connectors. These work like app connectors, but are required in order to aggregate and forward logs to your SIEM. Like regular app connectors, these should be deployed as a pair of app connectors, and these will need to be able to reach the internet, as well as being able to reach your internal SIEM or log connector. Here you'll want to make sure that you deploy your LSS connectors close to your SIEM or log collectors. LSS traffic will get balanced across all connectors configured in the LSS feed. Once app connectors and LSS connector are deployed, the final step will be to deploy ZPA private service edges if you wish to do so. These provide universal ZTNA with an on-premise deployment by reducing latency to and from the data center to the cloud, avoiding bandwidth consumption, and providing local policy enforcement. These also provide coverage for locations where Zscaler has no point of presence and enable business continuity so that ZPA can continue to be available in cases of internet outages, Zscaler data center issues, or routing problems. Private service edges will be covered in more details once we talk about business continuity. To conclude this video, here's an example architecture diagram. Here we have IaaS via AWS where a pair of app connectors are deployed within an app connector group. We have another app connector group deployed in Azure with a similar setup. Additionally, we have two interconnected physical data centers, for example via MPLS, each with a pair of app connectors deployed in their respective app connector groups. Also represented are Direct Connect and Express Route connections bridging our physical data centers into our cloud platforms respectively. This means that any of our app connectors can talk to applications in any location. However, the app connectors optimize the connections via their respective app connector groups, providing the end user with the best connection experience. That's it for this video. Thank you for watching.